The overall goal of this protocol is to determine the optimal restriction enzymes that will allow the characterization of recombinant vectors so as to digest and interpret the resulting cleavages by means of an electrophoresis.
Restriction enzymes or restriction enzyme classes are enzymes that cleave a DNA molecule in a particular sequence. These molecules have become an essential tool for the recombinant DNA technology. Different bacteria produce these enzymes to cleave foreign DNA as defense against bacterial viruses, like bacteriophages or phages, which insert the DNA into the bacteria. These are classified into four types or the basis for subunit composition, cleavage position, sequence specificity, and cofactor requirements. However, amino acid sequencing has revealed that at the molecular level there are many more than four types.
Type 1 enzymes are complex multi-subunit combination restriction and modification enzymes that cut the DNA at a random far site from their recognition sequence. They have small practical value since they do not produce discrete restriction fragments or distinct gel binding patterns.
Type 2 enzymes cut the DNA at defined positions close to or within the recognition sequences. They produce discrete restriction fragments and distinct gel binding patterns, and they are the only class used in the laboratory for routine DNA analysis and gene cloning. Most of these enzymes recognize DNA sequences that are symmetric because they bind to DNA as homodimers, but a few recognize asymmetric DNA sequences because they bind as heterodimers.
Type 3 enzymes cleave outside of the recognition sequence and require two such sequences in opposite orientation within the same DNA molecule to accomplish this. They rarely result in complete digest.
Type 4 enzymes recognize modified typically methylated DNA and are exemplified by the MCRBC and MRI systems of E. coli.
Recognition size can be analyzed in order to digest a vector in such a way that the clip fragments lead to distinct patterns when running an electrophoresis, and this can be used for processes such as northern and southern blotting, allele identification, a permutation analysis, and more. For a successful enzymatic digestion, there are a number of considerations that should be taken into account, such as the DNA quantity and quality, which should not be contaminated with salts, ethanol, or phenol, because they could inhibit enzyme activity. The enzyme quantity, because the amount of enzyme increases the amount of glycerol that is to be present during the reaction, which could lead to star activity. The buffer, the reaction temperature, and the reaction time.
Star activity of an enzyme is a general property of restriction endonucleases, which occurs when they are capable of cleaving a similar yet not identical defined recognition sequence, which happens under extreme conditions. The most common type of altered activity are single-base substitutions, truncation of the outer bases in the recognition sequence, and single-strand nicking. Others exhibit relaxation of sequence specificity under standard conditions and in presence of the cognate site are capable of cleaving non-conjugate secondary sites. This can be avoided by using the correct reagents, concentrations, and conditions of the different enzymes used, which can easily be determined using bioinformatic tools or at the provided website.
When a double digestion is to be performed, it is necessary to use a buffer that is compatible with both enzymes. Restriction enzymes are provided with specific buffer, but each enzyme has a different percentage of activity in diverse buffers. So tools like NEB Double Digest Finder provide information about the buffer recommended, as well as the optimal temperature for both enzymes and additional recommendations. Indeed, in some situations, the buffer or temperature is incompatible, and therefore it is necessary to conduct a restriction reaction with the first enzyme under certain conditions, such as incubation time, and activate it, normally with increasing temperature, and then proceed to the second enzyme. However, when the restriction enzyme is thermostable, it is denatured with phenol and precipitated with ethanol so the second enzyme can begin cleavage.
6 enzymatic digestion were carried out with two different plasmids from a blue and white colony. This is due to the fact that the restriction enzymes are to be used both separately as well as combined, so as to make sure that they are cleaving appropriately. The order in which the reagents are added are water, buffered with BSA, plasmid, and final enzyme, so as to preserve activity. This table shows the reagent and volume used for each reaction, where SHO1 corresponds to enzyme 1 and SK1 corresponds to enzyme 2. The 6 reactions were mixed in 6 different volumes or 0.6 milliliters in each microtube and incubated at 32 degrees for 1 hour. After this, the reactions were loaded into a 0.8% agarose gel, 0.5x T, CyberSafe 0.3x, and run for 60 minutes and 120 volts.
plasmids that were digested only with SHO1 resulted in a band of approximately 3,000 base pairs in lane 3 for the plasmid coming from a white colony, and 3 different bands with the plasmid coming from the blue colony, lane 7, at 3,000 base pairs, 5,000 base pairs, and higher than 10,000 base pairs. The plasmid digested with SCAL1 show a band at 3,000 base pairs at lane 4 for the white colony plasmid, and a similar pattern to the undigested plasmid from the blue colony in lane 8. Finally, the restriction digest with both enzymes shows that 2 different binds for the white colony in lane 5 at 2,900 and 1,400 base pairs approximately, and 3 different bands for the blue colony at 5,900, 4,000, and a faint band of 1,900 base pairs. The undigested plasmids for the white and blue plasmids are lane 2 and 6 respectively.
Lanes 3 and 4 correspond to the enzymatic restriction using SHO1 and SCA1 respectively for a white colony. They only show a well-defined band at approximately 3,500 base pairs, and with this, it is safely to say that the restriction enzymes could properly and did not represent star activity or a specific cleavage. Lane 7 and 8 show the same enzymes were used in the same order for the blue colony. However, in lane 7 for SHO1, 3 different bands are shown and only one should be present, indicating that the enzyme started to cut in different places corresponding to star activity, which could be originated due to the excess of some of the reagents during the preparation, or the enzyme was added incorrectly, giving such a result. Lane 8 for SCA1 show a similar band pattern to lane 6, which is the undigested plasmid for blue colony, meaning the enzyme wasn't present from the beginning of the reaction, or it would have generated at least one cleavage on 2 bands. This is completely attributed to human error. Finally, lanes 5 and 9 correspond to the restriction digest of both enzymes for the white and blue colony respectively. The white colony is expected to contain the insert and the blue colony to not contain it. Lane 5 shows a similar pattern to the plasmid with the insert in a clockwise position, agreeing with the in silico digestion, and lane 9 to the restriction digest without the insert. Therefore, the product insert for this specific colony is in a clockwise position.
A factor can be characterized with a specific digestion using restriction enzymes, and to prove that both the fragment of interest is present as well as correctly inserted, meaning that it is that direction that is desired. These must be carefully chosen, being that the one should always nick inside the fragment of interest and one outside so as to analyze the band pattern when conducting an electrophoresis. Such a digestion can only be successfully carried out when certain factors such as the pH, range of activity, magnesium cofactor concentration along with salt presence, glycerol content, and incubation temperature are duly respected.
RE have specific buffers in which they are most active and specific, which should be respected along with the specification that come along with. The addition of each reagent, and especially the enzymes affected the obtained results, being merely human error, but the verification of the presence and absence of the insert was indeed appreciated.